Hi, I hope you've done very well with your quiz, okay, and your assignment. I will check your quiz and your assignment, and I put your grades by the end of this week. So our next target is going to be in 2 weeks' time, which is going to be our test number one. By that time, we should be done with chapter one and a couple of sections. On chapter one and two, basically, we finish those two. So what we're going to do tonight is just checking section 1.6. Remember in 1.5, we talk about an inverse of a matrix and how we're going to find the inverse. We give that the inversion method if you like. So now we are going to apply it to a kind of a 3x3, a system of three equations and three variables most of the time. So what we do is we change the system of the equation into a matrix equation like ax equal to the b, and we use the inverse in order to get the solution. So that's going to be the topics of this 1.6, and easy sections that we can do it, but it's going to be very useful. Okay, so this is going to be 1.1.6, and we are going to consider systems of linear equation. Okay, systems of linear equations. And invertible matrices. Okay, invertible matrices. That is going to be the idea. So we are going to, the basic part is going to be this easy theorem that give you a relationship. How we're going to solve a matrix equation, getting help from okay, I'm sorry, go to my notebook. Okay, this is it. Okay, so that's it. That's what we're going to do is section 1.6. 1.6, we are going to see what's going to be a relationship between the system of the equation and the invertible matrix. So basically, we are going to use this theorem, interesting and easy theorem, because we change the system of the equation into the matrix equation. So how we're going to solve that matrix equation? So the idea is if A, okay, if A is going to be, if A is going to be an invertible, okay, invertible n by n matrix, okay, matrix, then for each, okay, for each n by 1, which is the column vector, okay, matrix of the constant, remember B, the system, okay, the system of equations. You know that system of the equations can be written as a matrix equation. It's going to be ax equal to the b has exactly one solution, one unique solution, namely that solution would be of the form of x equal to the A inverse B. That's it. We're going to talk about this one. So what we do is, you know that if a matrix A is going to be invertible, we can multiply both sides from the left by the A inverse. So A inverse A would be X, and we get A inverse B, and then you're done. Okay, so if you like the proof is going to be very easy. Okay, very easy proof, and this is going to be the case that if you have a solution, okay, suppose x is going to be any solution of the system, okay, any solution of ax equal to the b, then since the matrix is invertible, so we multiply both sides of the equation by a inverse from the left. Okay, that is going to be the case. Now the conclusion is going to be, you see, associative property, we can put the a inverse of the a together, and we have the x equal to the a inverse times b. But we know that this part is going to be an identity. So identity times x would be x. So x is equal to the a inverse of b, and that gives you the solution. So this is the thing that we did it. We knew this one when we solve a system of two equations, two variables. Now officially we put it over here. Okay, so it's clear. So a system of equation, linear equation would be given to, we change it into the matrix equation, ax equal to b. If this a, if a is going to be invertible, then this system would have one unique solution. And this is how we're going to find the solution, as we did it for the 2 by 2 matrix, okay, or the system of two equation, two variables. That's it. This is what we are going to do in this section altogether. So we get an example to test it, to see how we're going to do it. The example that I gave you the other night was a system of two equation, two variables. Now we're going to check a system of three equation, three variables, okay? So what we would like to do is, we'd like you to solve this system. This is the way we're going to ask you. We ask you to solve, okay, solve the system, solve the system, solve the system by finding, solve the system by finding the inverse. So that's the instruction. This means you are not going to use the, okay, augmented matrix or just idea of the Gaussian elimination method that we talk about. Okay, no elimination for this one. So make sure you know it, remember it for the, okay, for the test by finding the inverse. Okay, so what is going to be the system in question? This is going to be a system of equation that it is given. Okay, this is it. The system is x1 minus 2x2 plus 4x3 is equal to 12. And the second one is 2x1, second equation, minus x2 plus 5x3 is equal to the 18. Okay, 18. And the third equation is negative x1 plus 3x2 plus 3x2 minus 3x3 equal to the negative 8. This is the given system. You want to solve it by the matrix equations. Okay, so what we're going to do, we quickly change it into the, okay, quickly change it to the matrix equation. So this is going to be your solution. We're going to identify the matrix A. So what we're going to do, you're going to suppose that this is it. The matrix A is going to be matrix of the coefficients. So you suppose A to be equal to, you have 1, -2, 4. Then you have 2, -1, 5. And you have a -1. Okay, you have a -1, 3, and the -3. This is going to be the matrix of the coefficient. Okay, then you have a matrix of the variables unknown. This is going to be the unknown, x1, x2, x3. Then you have a constant matrix. The constant matrix is going to be, your B is equal to 12, 18, and -8. Okay, so this would change your system of the equation into what? Into A times X equal to the B. Okay, so that gives you x equal to the b. So if this a is going to be invertible, we don't know. So we put a question mark. We know that the solution must be of this format. Okay, so the solution x is equal to the a inverse b is going to be the unique solution if this matrix is going to be invertible. Okay, so what we're going to do, we are going to find the finding the inverse. So the question is going to be, what is the A inverse? Okay, what's the A inverse? Is there an A inverse? If it is, so we come back and we find the X. Okay, so that's the idea. Now, in order to find the A inverse, remember we talked about it, the inversion method. Inversion method, we start with this matrix and we put the identity matrix again, okay, against it if you like, and then we use the, let me just remind you how we're going to find it. Okay, remember you are going to form what is the matrix A, and over here the matrix I. You work on this one to change the A into the I, and the I would be A inverse. Okay, so this is going to be the matrix in question. This is it. You are going to go with A first. A is 1, -2, 4. Then you have 2, -1. Okay, 2, -1, and 5. And the third part was -1, -1, 3, and -3. Okay, that is going to be A. Now we introduce the identity matrix, 3 by 3, 1, 0, 0, 0, 1, 0, and we get the 0, 0, 1. So what we're going to do is, you know that we are going to change this one into, okay, this is going to be A, this is I. So we have to change the first one into the I, so the second one would be B inverse. So we have to change this one into the identity matrix. Gaussian form will give you the result. So we're going to do the first one is going to be, we got the 1, we have to change this one to the 0, 0. So we start with the R2. Okay, so R2 is going to be R2 minus 2R1. So that makes this one into the 0, and R3, you just add it to the 1 to get that number. Okay, so what's going to be the result? So the result is going to be, the first row is going to be unchanged. So we get the 1, -2, 4, and this is 1, 0, 0. R2 minus 2 R1, so that gives you 0. Minus 2 R1, and so that would be a positive 4, so that gives you 3. 2 R1, -8, so that gives you a -3. 2 R1, that makes it to the -2. And these are going to be, okay, so this is it. So we get over here, so that gives us, this is going to be just 1, then this is going to be 0. Okay, R2 minus 2 R1. So 2 R1, that make it to the positive 4, so we get a 3. -8, we get a -3 here. And this is going to be just a -2. And this is going to be 0 and a 0. Okay, now over here, this is R3 and R1. So when we add them together, that make it into the 0. So this is going to be a -1. And this is going to be 1, 1 here, and the 0 and 1. Okay, that's going to be the step 1. So we are done with the first column. So we get a 1 here. So we're going to change the other one into the, okay, we have to change the second one into the 1, and this one into the 0. So there are different ways to do it, to change it. We can avoid the fraction or just do it as is, okay? Because we have to change this one into the 1 eventually. So we have no other choice. We can switch these two if you like, to avoid the fraction a little bit, but eventually we have to do it. So we are going to switch the R2 and the R3, okay, to make it a little bit more easier to handle. So this is it. The first one would be unchanged. There are different ways to do it, but eventually you arrive at the same answer. So this is going to be 0. We get the negative 1, 1, 1, 0, 1. So and that's going to be 0, 3, negative 3, negative 2, 1, and 0. Okay, so let's make it a little bit better. Okay, so now we are ready for it. This is a negative 1, then we change it to the positive 1. And no, nothing to worry about. So we change the R2 into the negative R2 would be positive. So we have to make the top and the bottom 0. So to make this one into the 0, this is R1. You change the R1 into the minus, okay, minus 2R2. Take it to positive 2, and this is going to be R3. We change it to the R3, and this is going to be just plus 3R2. Okay, 3R2, make it into 0, and then we'll be fine. So we are going to continue. This is it. So R1 minus 2R2. This is R1 minus 2R2. So that give you 1 minus 2R2, that make it to the 0. Negative 2R2, that make it into the 2. That is going to be negative 2, which is going to be negative 1. This would be 0. Okay, 0, negative 2R2, that give you a negative 2. Now we multiply this one by a negative 1, negative, negative 0, and a negative 1. Then R3 and 3R2, so going to be 0, and this is going to be 0. Okay, that's it. It's going to be 0. 3R2 make it into the negative 9, so that's a negative. Okay, R3 plus 3R2. Okay, so 3R2, that would be 0 again. Okay, R3 minus 3R2. So that give you 3R2, which is going to be a 0 here. Okay, then this is negative 3. That make it into the 0 here. Okay, and let's see if we missed anything. So what we did, this is a negative 3, negative 2, 1, 0 that we have. Okay, so I want to check this one. So that means 0. I need a 1 here. So this is going to be 0. In that case, we cannot continue with this one. So just double check to make sure that everything's all right. So the negative 1, 3, negative 3. I did this one all right. And then I did the R3 and R1 to get this one. R3 and R1 is 0. Oh, that's a positive one. You see R3 plus R1. That is going to be a positive one. Okay, so that would be a positive 1. This is a positive 1. And everything else is correct. Okay, R3 plus, okay, R3 plus R1. So that give you 1, 1, 0, 1. Yes. So this is going to be a positive 1 because, I know that this system would have a solution. Okay, so this is going to be the case. We don't have to multiply it by, okay, we don't need this one because we already got the positive 1. So that give you a positive, positive, and positive. And now then we'll be fine. R3 and 2R2. Okay, this is it. We need a negative 3R2 now. negative 3R2. So that would be 0, and this is it. This would be a negative 6. Okay, this would be a negative 6. And then over here, this is going to be negative 3. So that make it to negative 5. Negative 5, then this is 1. And 3R2, that give you 3. That's better now. Okay, so that's it. So what we did, we have the 1, 0, 0 here. So we have to take care of this last part. Now it's unavoidable. You have to divide it by negative 6 to be able to continue. Okay, so divide by negative 6. This is it. So we divide this one. This is R3. It's going to be negative 1, 6 R3. It's going to be fractional, but I try to avoid the fraction as okay, as far as I can, or as long as we can. So we change the last one, and then we'll be almost done. So this is going to be 1, 0, 2, negative 1, 0, negative 2, and change 0, 1, 1, 1, 0, 1. Divide by a negative 6, make it 0, 0, 1. That give you 5, 6, negative 1, 6. And this is going to be 3, 6. Okay, is going to be negative 3, 6, which is going to be negative half. Okay, I divide each one of them by a negative 6. Okay, we are almost done. We got the one here. You have to take care of the others. So this is it. R2 into the R2 minus R3. You get a 0 here. And to get the 0 on the top is going to be R2 minus 2R3. And then you're done. Okay, so this is it. So R1 minus 2R2. So that's going to be 1, 0. Okay, 2R3, that make it to the 0. 2R3, if you multiply by this one, that give you negative 5/3. Okay, because this is, okay, this is going to be negative 1, 2R3. So this is going to be negative 5/3 and the negative 1, negative 5/3 and the negative 1 is okay. So we get the negative 1 over here, and we have a negative 5/3, which is going to be negative 8/3. Okay, and that is it, because I multiply this one, that give me negative, okay, negative 5/3. So that would be negative 8/3. Okay, it's going to be negative 8/3, negative 8/3. And over here, R1 minus negative 2R3, that give you 1/2. Okay, and here it's going to be negative 2. This is going to be negative 2 times negative 2 would be 4. And that's going to be 4 minus 1/2. It's going to be 3.5. It's going to be 7/2. Okay, 7/2. Now R2 minus R3. That is going to be easy. Okay, that's going to be 0. R2 minus R3, that gives us a negative 1/6. Okay, this would be positive 1/6. And this is going to be 3/2. 3/2. So this is it. Now we are almost done, because the last one is going to be 0, 0, 1. And this is going to be 5, 6, and negative 1/6, and negative 1/2. Okay, so this is going to be the matrix. We got the 5, 6, and negative 1/6, and the 1/2 is a 1, 6, 1, 6. And this is going to be, not quite sure about this one. You know, if we check it, we can check it later again. or you just check it, make sure you get it right. Okay, so basically this is going to be, so I got the identity. So this must be A inverse. Okay, this is going to be the A inverse, and then we are done almost. Okay, to get this one. Okay, so let's check.